Okay, we're looking at exercise 11C from the first year mechanics textbook. We're on question 5. So we've got a particle and we're given its distance in terms of time. First thing we're asked to do is to sketch a displacement time graph. And we're told that t is only from 0 to 4.5. So those of you with graphical calculators, you can just plug it straight into that. But they'll only ask you to sketch functions that you should be familiar with from core. So we know what a cubic graph looks like, and we should be able to sketch one. So let's have a go at that. So question 5, and S is 9 over 2t squared minus t cubed. So if I want to sketch a graph, I want to sketch a cubic, I want it factorised, so I can take t squared out as a common factor. And then obviously 9 over 2 is 4.5, and that's that was the upper value of t, so that's relevant to this. So I've got a repeated root at t is 0 and a root at 9 over 2. So if I was sketching the whole graph, and it's a negative t cubed, so it's a negative quadratic as cubic, sorry. So if I was sketching the whole graph, it would look something like that. Okay, so I've got a bit ahead of myself there. So that's what the whole cubic would look like, and that's something that we should be able to sketch from our core maths. And they've asked for a displacement time graph, so we'll come back to that. But t is only between 0 and 4.5. So going back to my graph, it doesn't really exist. So if I can, a little bit smaller, I'll see if I can. Oh, I knew that would happen. Okay, so no worries. I'll just sketch that part of it again. So okay. So that's the only bit of my graph, and I do want to make sure it does look like there was a stationary point at 0, so it should kind of flatten out as it comes into 0. Okay, so there's my sketch for part A. Right, and then part B, hence justify the restriction. So why does t only exist between 0 and 4.5? Well, t has to be greater than 0 because it does. So got to change screens. So t has to be greater than 0, greater than or equal to 0, because time cannot be negative. Okay, so just a note to justify that end of it. And why the 4.5? Well, obviously 9 over 2 is 4.5. We need to be careful with how we phrase this, because displacement can be negative, so we can't use sort of that justification, but it says it's the distance, and distance can't be negative. So they've been a little bit sneaky there. But so t has to be less than 9 over 2 because distance can't be negative. We've shown in our graph that when t is greater than 9.2, we would be into negative distances. Okay, find the maximum distance of the particle from the origin. So we're on to, so that's going to crop up pretty much every type of in all of these questions, maximum and minimum. So I can see on my graph it's there. So I'm looking for a stationary point. So S is, so I want it back. I want the expanded version if I'm going to differentiate. So the stationary point of that. Let's put that a little bit. So I'm going to differentiate S. So when I multiply by 2, the half will cancel, and that'll be minus 3t squared. I'm after a stationary point. So let's, don't know what I did there. Right, we'll take 3t out as a common factor at the same time. So if I take 3t out, I get that. So I've got a stationary point at t is 0 and t is 3. And I knew there would be one at t is 0 because we already knew from our sketch there was a stationary point at t is 0. So the one I'm interested in is t is 3. I can see from my sketch that when t is 0, it's the minimum, and when t is 3, it's the maximum. So I don't need to justify that. but they didn't ask for the time, they asked for the actual maximum distance, so don't forget to do that. So I just need to then say, okay, so when t is 3, the displacement, so I'm using this equation here, is 9 over 2 times 3 squared minus 3 cubed. So let's have a look at that. So 9 over 2 times 9 minus 27. So you get 13.5 meters. Okay, and then part D, find the magnitude of the acceleration of the particle at this point. Okay, so just a little bit more differentiating to be done. So I've got the displacement. I've actually already differentiated that here. Sorry, I've got to change screens. Right, so got the displacement. Here, I've already differentiated. So I didn't refer to it as the velocity, but that's what that does give me. So I've got the velocity. So acceleration, I just need to differentiate again. Okay, and is that all they wanted? Yeah, so find the magnitude of the acceleration of the particle at this point. Okay, so at this point is when t is 3. So when t is 3, it's 9 minus 6 times 3. So that's going to give me minus 9. And the significance of saying the magnitude is we don't care about the negative, we just want the size of it. So that's 9. And let's just check those answers. Job done.